right, so thank you for inviting me to share some insight on how demand-driven applies to the shop floor, really. And when we enter the manufacturing environment, we go beyond what we've seen till now about DDMRP, which is very much focused on inventory management, and we'll enter the shop floor. And when we go into a manufacturing environment and enter a shop floor, usually I would encourage you to ask yourself the next questions. Do you see the material flowing? And it's not always easy to see material flowing, particularly if you're having complex operations with multiple steps within your manufacturing environment. Do you see what are the critical steps? What are the constraints, the bottlenecks that pace your flow? Do you see easily if you're ahead or behind schedule? And do you see what to build next? So the whole purpose for demand-driven scheduling and execution will be to connect what we've seen earlier on, which is clear signals, demand, actual demand-based replenishment, and translate it into visual signals on the shop floor, so that your operations, your manufacturing operations, are fully synced with the overall model. So depending on the complexity of your environment, you may or may not need additional refining on your scheduling practices. Typically, if you're having simple operations, and I'm taking here the example of a bottling operation, it's a flow line, so you would typically just benefit from stock buffers and clear prioritization with critical, high, medium, low priorities in order to schedule your production, to take into account your campaigns, etc. So that should be good enough just to use DDMRP buffers to be able to drive this production properly. And you can get into some basic finite capacity processes, group planning to organize your campaigns, etc. That would work fine. But when it comes to more complex environments, and this is a live example from a company manufacturing aerospace parts. So if you have complex routings with multiple steps, with I don't know, turning, grinding, milling, whatever operations, and some variability here and there, because you can have quality issues, you can have people off sick, the operation didn't show up, etc. Then it becomes way more difficult to really stick, commit to dependable promise dates and stick to those promise dates and properly deal with the priorities on the ground, on the shop floor. The same applies if you're in a mixed environment where you would manufacture some of your products to stock and therefore use inventory buffers, DDMRP buffers for your make-to-stock flow. But as well, you have some orders that are manufactured to order or even engineered to order. And how do you deal with consistent priorities in such an environment where you have to use the common resources for either make-to-stock or make-to-order products? That's not that simple, and that's where demand-driven scheduling and execution comes into play as well. So what are we talking about? We've been talking about sales and operations planning this morning. Sales and operations planning is helping us to set the right parameters for our supply chain, for our inventory buffers, etc. But then when the DDMRP order generation logic generates work orders, Then you enter this scheduling step, which is basically defining with finite capacity process, defining the due dates and when each work order may run on a given operation. And then there is another layer that we'll dig into, which is how do we execute on the floor and make sure we are on time, or we properly prioritize the operations. So in order to get there, we complement the inventory buffers Ziad alluded to earlier today, and we add two additional mechanisms. One is what we call time buffers. You can see time buffers as being queues, because in any manufacturing environment, you do have queues at some steps. But in order to get queues that just accumulate because you're pushing material, you organize time buffers. So you organize queues and you monitor their status with red, yellow, green positions ahead of some critical operations within your flow, or just before shipping the shipping point to your end customers, for instance. And we also monitor capacity buffers. So we look at our resources and identify the ones that are constraints and the ones that have some slack capacity. And we monitor this slack capacity to make sure we do not have moving constraints within our operations. So what are time buffers? Time buffers will be queues. They will help get the right priorities to the shop floor guys, to the operations supervisors, and delegate to some extent to the shop floor the degree of freedom on which work order should we work on first. These time buffers will enable protecting the critical operations within the flow, make sure everyone gets a common view on priorities, and it's really a visual management tool. So we'll see that in a minute with some examples. Control points will also be used in this model, and control points are typically bottlenecks. For instance, if you have a constraint in your system, you want to make sure you drive your schedule based on the pace of that constraint. And there will be as well the flow exit and entry point. So when are we shipping products to our end customers? When are we staging inventory in the finished goods inventory warehouse, or when should we release work orders? We can have as well other control points within our manufacturing flows. So for instance, if all of the work orders or many work orders are going through a quality inspection step, for instance, this quality inspection step can be as well a very good control point to monitor priorities on the shop floor. So the first thing we would do when implementing demand-driven scheduling and execution is to create a model of how the manufacturing steps take place. And those are some examples of the models we can sketch. So we are representing the flow map of the various manufacturing operations. We are inserting inventory buffers. Those are those icons here. When it makes sense to have inventory buffers, we'll have inventory buffers inserted, but sometimes you cannot just put inventory. It's ready made to order products, for instance, so you will organize time buffers, and we'll identify as well what are our constraints, the drum here, and what are our critical control points, for instance, when I start a work order, and for instance, when I ship goods to my end customer. So the first step is really to design this model. And in this model, we'll have, for instance, the drum, which is our bottleneck, the constraint. We'll have time buffers that will, so here in this example, one is protecting the drum and one is protecting the shipment to end customers. And then I will have resources, and then I will have flow profiles. So we'll group items depending on what their manufacturing processes are, and items that will have similar routings will be dealt with in a common way. Once we define the model, so typically what we do by defining the model is really creating some kind of digital twin of the manufacturing operations. Once this model has been defined, we'll schedule it. So typically here we have a drum. This drum is both replenishing some inventory, but is also used for make-to-order manufacturings to fulfill sales orders. So we have signals that are replenishment signals for the inventory buffers. We have signals that are sales orders coming from end customers. And what we start doing is finite capacity scheduling that drum, so that we generate a schedule that is realistic, that we'll be able to stick to, and we level out based on the right priorities. So based on the status for the inventory buffers, red, yellow, green, based on the due dates for the end customers, we combine all that to generate a schedule on the drum. And we'll commit promise dates to the customers based on that realistic schedule on the drum and based on the protections we inserted with the time buffers after the drum and before shipping to the end customer. So how does it look in practice? It's a scheduling workbench that will enable you to, for instance, create planning wheels, group campaigns, use the right priorities, expedite some orders. So it's really a semi-automated, automated scheduling process, but with a human intervention possible, of course, to deal with particular situations. Once the schedule is generated, we'll release the work orders to the shop floor. So this means that the shop floor have direct access to the priorities and to the work orders. And what is key in this model is that we'll use those time buffers we inserted to monitor the priorities on the ground. So typically what we have is buffer boards, and those are displayed on LCD screens on the shop floor in the locations where we organize time buffers. So this is, for instance, before our critical process step here. We have this buffer board. On the lower part of the buffer board, we see the work orders for which we already have everything available to run on that constraint. So basically, we know that we need to run first this work order here that is late, and then we'll work the two yellow ones, etc. And on the upper portion of this board, we have the work orders that are not yet available on that process step, and that the upstream
Bernard, you turn off your microphone now. Turn it on, please.
Can you hear me? Yep. Okay.
Yeah, already.
Can you hear me now?
Yes, yes.
Okay, thank you. All right, so here we have those buffer boards that are displayed on the ground, and the standing meeting, the production meetings are happening before those buffer boards, and everybody has the very same understanding of what the priorities are, and are we ahead of time or ahead or behind schedule, etc. So this is very visual, very simple management, and there are a number of visual management tools that are deployed on the ground to support this approach. The next thing is that once you started and once you executed on this, so for instance, when you have a queue here, you will record whether your work orders, your jobs are arriving in this queue ahead of time, on time, or late. And depending on that, you will accumulate data over time, and you will be able to use this data to collect stats. And for instance, this is a live example from an implementation. On a given time buffer here, most of the work orders were arriving early, blue, and some were arriving late. And then this company has been able to drill down into what work orders and what type of operations are arriving late, and what is causing the late deliveries in that buffer, and reversely what is causing those early deliveries, and they were able to reduce the routing and shorten the lead times on some of the items, because basically they realized they were able to deliver faster those work orders. So to summarize, and that will be my last slide for this presentation. To summarize, demand-driven scheduling and execution is really the shop floor manufacturing leg for the DDMRP and DDOM model. It includes finite capacity scheduling for the constraints, and so that you can exploit as best as possible your constraints, minimize changeover times, optimize the sequences, the planning wheels, etc. It's including group planning and scheduling. It enables you to commit to realistic due dates, realistic promise dates, with realistic lead times that are consistent with your capacity and protected with time buffers from variability. It enables visual management on the shop floor and fully digitized full flow on the shop floor. We do not release any work orders before when it should be released, so we are as well controlling the working process and making sure that this will enable fast operations. And this is really consistent priorities throughout the shop floor operations for both make-to-order and make-to-stock flows. So this was very brief, but I hope it was clear enough for you to understand. Any question, Ziad, at this point?
Yes, Bernard, we have questions, so I will briefly read on Russian, then on English. Коллеги, у нас есть вопрос аудитории. Каковы ограничения самой модели DDMRP? Не может же быть такого, чтобы ее можно было использовать везде, например, услуги, управление деньгами и так далее. Bernard, so the question is, what is the limits of the DGMRP model? This just cannot be that you could literally implement it everywhere. For example, services, cash management, etc. Maybe some productions. What are the limits?
That's a very good question. At the very beginning, when I learned DDMRP, and this was back in 2014, I was told DDMRP applies to products that have a lot of flow, that fast-moving consumer goods, for instance, so products with high volume, make-to-stock, etc. And the reality is that we see over time more and more companies adopting DDMRP and a full demand-driven operating model, even in engineering to order, complex equipment manufacturing, etc. So this is not, it's a framework. DDMRP and the demand-driven adaptive enterprise model is a framework. So you need to adjust it to your own company and your own model. And that's why here you've seen the first step is really modeling. So it's key that the model is in line with the reality of your company. But any company, I believe today, manufacturing and distribution company, I believe today is able to benefit from the model.
Yep. We got one more, again, Russian, English. В случае непригодности длительного годового, например, планирования и переход на ситуативный анализ, каким образом осуществляется планирование PPR-оборудования, требующее длительной остановки производства и постановки комплектов запчастей? English one. In case if we have not really precise the annual planning, how then we can switch to the operational analysis, especially when you have the long maintenance, long setup times, and you have real long time for supplying long lead time spare parts for the equipment. How would you manage this one?
Well, it's again about creating the model that represents your depicts your company and your constraints properly. Whatever your constraints are, at a point in time, you need to meet the customer demand. So at a point in time, you need your model to accommodate actual orders and to be able to fulfill actual orders in a relevant way. So if you have long lead times, if you have changeover times and campaigns you need to run, you can certainly make your model, design your model to comply and represent those constraints. But
yep.
What the DDMRP model and DDOM model is urging us to do as well is to look into what are those constraints for, and can we elevate some of them, and can we build more agility in our model, because eventually in a never-changing world we really need to create more agility. I don't know if I fully answered the questions yet, but
yeah, I think yes. I will add also a few words for the our audience. Basically, as Bernard said, we have to remember that in the demand-driven operating model, we got stock buffers, time buffers, and capacity buffers, and basically all of them are interchangeable. So as Bernard said, all in the design, so you can design it. Probably it.
Thanks, Bernard, for your presentation.